Parallel circuits. Okay, a parallel circuit is different from the series circuit, that in a series circuit the electricity has to go through all the components. In a parallel circuit, the current has a choice as to where to go. So at the top one there, you can see the electrons could probably go around entirely around the black loop, but some electrons may choose, instead of going through the black lamp, may go through the red lamp, and some electrons may be able to go follow the green lamp. So it's got a choice as to where it goes. Obviously, it's not as if electrons choose where to go; they just simply react to the pressure behind them. So in the same way that if you have a hose pipe, and you just have a single hose pipe, the electrons have to go all through the pipes, but if you start drilling holes into the side of it, water will flow out of those different places. And it's the same with electrons. One of the things to notice here that is different from series circuits is that if one of the bulbs blows, say the black one blows, the red and the green will still stay on because the electrons can still get around. Right, something we need to know about cells and batteries. If you get one cell, which you call a battery, but should really be called a cell, and attached to it another one in series, then the effect it actually has is of you add the two together. So if each cell is worth 2 volts, and you put two of them together, in series it forms 4 volts. However, if you connect these batteries in parallel, as seen as the diagram on the right hand side, each one with 2 volts, you still end up with a voltage of 2 volts. Basically what it means is the batteries will last longer because they're in parallel. Right, some rules we need to know about parallel circuits. Well, in the series circuit, obviously the current was the same all over the circuit. However, in parallel, because the electrons could choose where to go, something different happens. So I'm going to start here at the battery. You can see where the battery is. We're going to follow the arrows around. You can see as it goes around, this time anti-clockwise, it hits a 5 amp ammeter. Then it reaches a junction. 1 amp goes along the top lamp and 4 amps start to head towards the bottom. 5 went in and 5 must come out. So 1 plus 4 equals 5. And then if we go a bit further down, you'll see that the 4 amps, 2 amps goes along the middle lamp and 2 amps goes along the bottom lamp. So again, 2 plus 2 will make 4. And of course, once the electricity has gone through the middle lamp and the bottom lamp, the current rejoins. The 2 amps from the middle and the 2 amps from the bottom lamp will rejoin and form 4 amps. And as it starts going up the right hand side there, 4 amps is going up, it then meets the 1 amp coming in from the top lamp, and you have 5 amps flowing back, showing that you cannot destroy the current or create it, but it will split. So that is the big difference between parallel circuits and series circuits. In voltage, what you need to know is that whenever the electrons go to the battery and pick up voltage, say 2 volts, it must expend it in its journey around the circuit. So if one of them goes around, say, the top loop there, it picks up 2 volts and drops off 2 volts at that lamp. But if some electrons may follow the bottom loop, and of course if it picks up 2 volts at the top, it must also spin 2 volts at the bottom. Example 2 is actually showing you the same thing, but if you notice this time there is one loop where it has to go through 2 lamps, and what we're showing here is that it picks up 2 volts of energy from the cells at the top there, and then it will drop off 1 at each of those lamps. 1 plus 1 will equal 2, which of course is the amount of energy supplied by the battery at the top. The lamp at the bottom, any electrons that instead of going through the middle row just decide to go around the bottom row, will drop off all their energy at the bottom one. So the bottom lamp will be brighter than the 2 middle ones, because the 2 middle ones are only getting 1 volt each, whereas the bottom one's getting 2 volts. Resistance is a bit more complicated. We don't really need to go into equations for this, but in resistance, basically the more lamps you add, the easier it is for electricity to get through, bizarrely. So whereas that's different from series. In series, you put them lamps in series, it gets progressively harder and harder for the electrons to go through. Actually, when you connect them in parallel, it becomes easier for the electricity to come through. And that is parallel circuits.